So let's try it on some polynomials in a very similar manner. Okay, so we want to divide this polynomial by this polynomial. So we're going to say x minus 4 into 6x squared minus 26x plus 12. Okay, so just like before, we're going to take the divisor and see what we can put it into. Now, in order to put it into something, we have to have the same number of terms. So, what we would need is 2 terms. So, I'm going to have to take x minus 4 and put it into these 2 terms. Okay, that's what we're trying to do. Now, in order to do that, what we do is look at the leading terms. So this x here and this 6x squared. Okay, so what I want to do is I want to say how many times does 6 go into 6x squared? In other words, what would I have to multiply x by to get to 6x squared? All right. So what's nicer here is I don't have to think about going over or under or anything like that. It's very clear. If I want to get to x to 6x squared, I would multiply by 6x. And I'm going to put that over what amounts to the x's column. All right, so this all here would have x terms in it. So once I've decided that, I'm now going to take what I put up here and multiply it by my divisor, just like I did with numbers. All right, so what happens when I do that? 6x times x is 6x squared, and 6x times minus 4 is minus 24x. Okay, and then I'm going to subtract. Now we use some parentheses here because we're subtracting polynomials with multiple terms likely, so we want to make sure we distribute. So now let's look. Well, the first 6x squared minus 6x squared gives us 0. Well, that makes sense because that's why we chose the 6x there to multiply by x to give us the 6x squared. So that is very logical. So I'm going to get rid of that. So then minus 26x minus 26x. In other words, minus 26x plus 24x, I'm sorry. So minus 26x plus 24x would give us a minus 2x. All right. So now we're basically at another starting point. We're thinking about x minus 4 going into minus 2x, but that can't happen because that's 2 terms into 1. So I need another term. I bring down this plus 12. Now I try to put x minus 4 into minus 2x plus 12, which really means I look at the leading terms. And I decide how am I going to get from x to minus 2x by multiplying. Well, I would have to multiply by minus 2. So I put minus 2 there. And then again, I'm going to multiply this by this. Minus 2 times x minus 4 gives me minus 2x, and minus 2 times minus 4 is plus 8. All right, and I subtract. So the minus 2x minus negative 2x is minus 2x plus 2x. I get 0. I should. That's why I chose the minus 2. And then 12 minus 8 gives me 4. Okay, so now I don't have any more. And notice that the 4 is now a lower degree than the x minus 4. So that means I'm done. I can't go any further. Also, I have no more terms. That's also telling me I'm done. So there is your remainder. So I can do remainder of 4. Okay, so what does this really mean here? Well, again, it means that I can take the dividend 6x squared minus 26x plus 12 and express it as the divisor, x minus 4, times the quotient, 6x minus 2, but then I need the plus 4 because that's the remainder. And so what I've done is I've essentially broken this down as almost a factoring, but with a remainder. Okay? Let's look at another one. All right, so this time, a little more complicated. We're going to divide this 4th degree polynomial by this quadratic polynomial. All right, still applies the same way. 2x squared minus x plus 2 is getting divided into 8x to the 4th. Oh, I noticed that I'm missing an x to the 3rd. To keep everything column-wise and structured, what you should do is put in a 0 term for anything that's missing. So I'm going to put in a plus 0x cubed plus 6x squared minus 3x plus 1. Now you wouldn't have to do that, but in order to keep all the columns organized, that is by far the best way. All right, again, I'm going to try and take this and put it into the first 3 terms because it has 3 terms. In order to do that, though, I just look at the first terms and I say, how am I getting from 2x squared to 8x to the 4th? Well, I would have to multiply 2x squared by 4x squared to get from 2x squared to 8x to the 4th. So I go to my x squared column and I put 4x squared. Then I'm going to take this and multiply it by this whole polynomial here. All right, 4x squared times 2x squared gives me the 8x to the 4th I'm expecting, because that's why I chose it. Then 4x squared times minus x gives me minus 4x cubed. 4x squared times plus 2 gives me plus 8x squared. And I would subtract. Okay. So, what do I get? Well, I get 0 out of the first term subtraction, as I should expect. Then I get 0x cubed minus 4x cubed. Well, that's 0 plus 4x cubed, so that's 4x cubed. All right. Then I get 6x squared minus 8x squared, which is minus 2x squared. All right. I only have 2 terms there now. I'm using something with 3 terms. I have to bring down another term. So I'm going to bring down the minus 3x. And again, start the procedure over again. Put the 2x squared, how does it go into 4x cubed? Well, I need a 2x to get there by multiplying. So, oops, plus 2x. All right, so now I do that multiplication. I'm going to multiply this plus 2x by this 2x squared minus x plus 2, and what do I get? Well, 2x times 2x squared gives me 4x cubed, as I was expecting. Then 2x times minus x gives me minus 2x squared, and 2x times 2 gives me plus 4x, and I subtract. So now I do that subtraction. I get 0 from the first subtraction, which is expected. Now I happen to also get 0 from the second one, because minus 2x squared minus 2x squared is actually 0. Now that can happen. It wasn't guaranteed to happen here, but it did. So I go to the next one. Minus 3x minus 4x is minus 7x. Okay, so now I take a look. But look, this is a second degree polynomial. This is a first degree polynomial. I've arrived at something that's lower degree. I have to be done. But I still had a plus 1 here. It has to come down, but that's my whole remainder now. So that's what I have. okay? Which means that the 8x to the 4th plus 6x squared minus 3x plus 1, I don't need the 0 term in there for this, equals, so that dividend equals the divisor 2x squared minus x plus 2 times the quotient 4x squared plus 2x, and then I still have a remainder of plus negative 7x plus 1. Okay, so here our remainder indeed can have x terms in it. It can have x terms up to the power below the divisor. Okay, so there we go. Again, it seems like we've almost broken this down into a nice product of two things, but we still have a remainder.